Okay, so in matrices, we're going to do three things today. The first two are basically the same thing, just one minor difference with them. First thing we're going to do is we're going to look at addition and subtraction of matrices. And this is really straightforward. As far as what a matrix looks like, it's going to have a kind of brackets around it, and everything will change. The different sizes and different things kind of go with this one. All right, so each one of these is going to have basically it's like a location. They call them elements. They call them different things. But basically, the very first number, if you were doing this, would be like A11. It's in the first row in the first column. The next number would be like A12, where it's in the first row and it's in the second column. If you go below that, it would be A21 and then A22. Okay. And again, big thing is remember is that when those are like subscript numbers because they're on the low side, they're not exponents because they're not the top, they're in the bottom. So in that case, the 3 is going to stand for the third row, and then the 4 means that's the fourth column. Okay, so it's basically it's just a location is what it's talking about for that one when you go through those numbers. If you change the way they talk about matrix or different matrices is they'll use different letters to talk about different things. So if you talked about matrix B, well then we're talking about B11, B12, and if you had three numbers, it'd be like B13 because that would be the first, second, and third column, still all in the first row. Below that, it'd be B21, B22, and then B23. Okay, so it's just an identification way of saying, okay, here's the location of wherever this certain number is going to be. It's on the third row, and then you go to the fourth column. This is the case. This is the second row, and this is the third column. So it's just it's a tracking type thing where you're figuring out where these points and where these locations, where these elements of the matrix will wind up being for this one. If they ask you to add two things together, you just have to, like, say, if we were going to do A plus B for something like this. Now, technically, for this one, we should have said that B would have been, should have stopped right there for that part. But let's just say that if you have to do A plus B, then you add basically you just add elements in the same location. Okay, so you can just kind of take a break on that one because those two are just kind of talking about the different sizes of things. So when we talk about A plus B, you're just adding elements in the same location. So you're going to add, it'd be A11 plus B11. It'd be A12 plus B12. Same thing if you go to the second row, it'd be something like that. Okay, and again, the key thing is that when you're adding and subtracting matrices, they have to be the same size. Bless you. Okay, so if they give you, two different size matrices, you're not able to either add them or subtract them. And that's where, if we kind of backed up for just a second, if these were the two matrices we had, you couldn't add or subtract these. That B would have to be basically that size. They both would have to have two rows and two columns to do that. If we tried to add these two together, that would be one that would just be not possible. Okay, so there's what we're doing. There's what we're kind of going through on this thing. All right, so let's give you some actual numbers so you can kind of see what's going to happen to it here. So let's say that A is -12, 24, -3, 5, and -110. All right, for B, let's go -3, 1, 2, -4, and -1, 5. Okay, and we'll go ahead and do both of the options that you could possibly do in this one. We'll do A plus B, and then we'll do A minus B, just so you can kind of see what's going to happen with these. Okay, so finding A plus B. So we're just going to take, and again, basically just take it one piece at a time. This is the top left number. You add it to the top left number here, so it's just -12 plus -3. Go to the top right number is 24 and 1, so it's just 24 plus 1. Oh, sorry, I didn't go far enough down. All right, next one on your next row, you've got -3 is the first number in the second row. Do the same thing there. Take the first number in the second row, so we're going to do -3 plus 2. All right, and we'll do the same thing here. We'll do 5 plus -4. All right, and at the very end, it's -1 plus -1. And then it's 10 plus 5. All right, and you may be asking me, do we have to show this step in the middle? No, this is just making sure we don't get too fast, too quick on this one. It's basically just showing you the thought process that you want to go to. So adding, it's just this number plus this number, and that's what we get here. So your final answer over here to the left, if we do -12 plus -3, that's -15. 24 plus 1 is 25. -3 plus 2 is -1. 5 plus -4 is also 1. -1 plus -1 is -2. And then 10 plus 5 is 15. Okay, so addition, pretty straightforward. Not really anything sneaky at all about it. Just take the numbers, add them up, do what you need to do with it. The only one you have to be, and it's not even hard, you just have to be careful with it, is that if you do subtraction, just like when we were doing the operations, let's see, was it last week? Yeah, I think it was last week. We're doing function operations, that if you were doing subtraction, it wasn't hard. You just had to be careful with it because of how it was set up. When you do A minus B, that's going to be the same thing. It's not hard. You just have to be a little bit careful with it. All right, and again, the only difference is instead of putting plus signs in the middle here, we're going to put a minus sign. So it's -12 minus. And if you do minus a negative, you probably want to put that negative number in parentheses, just because it'll help you kind of see it when you get to it. For this number, if you do 24 minus 1, you don't really need a parentheses because the 1 is just a number and it's fine. It's okay on that one. So if you have to do minus a negative number, I would put that negative number in parentheses. If it's just a regular number, don't worry about putting it in parentheses. All right, if we go to the second row, it's -3 minus 2. And then it's 5 minus -4. All right, last row, it's -1 minus -1. And for the second number, it's just 10 minus 5. Okay, again, the only difference between addition and subtraction is everything up here was a plus sign. Subtraction, everything's just a minus sign. And again, really the only thing that you're going to have to do is where you've got the minus negative is think that that's really -12 plus 3. So it'll make that -9. 24 minus 1 is 23. -3 minus 2 would be -5. 5 minus -4 would really be 5 plus 4, so that'll be 9. -1 minus -1, that's -1 plus 1, and that'll be 0. And then 10 minus 5 would be 5. Okay, so again, not hard, just be careful with the subtraction sign because, again, sometimes with subtraction you do have to change a sign or two, just depending on the numbers and how they kind of set up in there. So, the only other thing that might pop up occasionally on these is they may talk about, if we back up for just a second, back up here, if they talk about matrix A, they might ask you for the size of it or the dimensions. That basically you just tell me how many rows and columns it has. It's got 1, 2, 3 rows and then 2 columns. So that size, if they talk about it, would be a 3 by 2 matrix. Because you have, it's always kind of like we did back up here with this one. It's always the rows first and the columns second. So if you talk about the size of it, you do the same thing. Tell me how many rows it has. So that's 1, 2, 3. And then tell me how many columns it has. So then just 1, 2. And again, because we're going to add and subtract these together, then B would have to also be the same size. It would still be a 3 by 2. So they talk about the size of it. Just realize you're telling me how many rows it has and then how many columns it has. That everything we do is rows first and then columns second. Okay. What they'll do after that is if that's okay and everything's pretty straightforward there, they may ask you to solve a matrix equation. And it's the way we're going to, again, there's a couple of different ways we'll go with it. But this one's still basically going to be solving by adding a subtraction. All right, they'll do something like this. They'll give you 2 different matrices. So let's say B is 1, 6, -1, 2, 6, 1, and then -1, -2, 4. And C is 2, 0, 0, -1, -3, 6, and 2, 3, -1. Okay, and then they'll probably ask you to either solve. They'll give you a different matrix, and it may be that it's, it could be A, it could be, Y, it could be Z, it could be anything. We'll just say in this case maybe it's X. And then I may say something like this, that X minus B is equal to C. So they'll ask you to find X. Okay, so first thing you'll do is you'll basically take this equation that you have here where you got this part of it and basically just solve it for X because that's what you're going to do. So it's X minus B, so to get X by itself, you would just add B to both sides. So X is going to equal C plus B. Okay, and once you know that, well, now we'll go down here below that and we'll actually take matrix C, add it to matrix B, and then that's all we have to do for the answer there. All right, so if we do C plus B, and we'll just kind of go ahead and do it from right here, it's 1 plus 2. It's 6 plus 0. It's -1 plus 0. It's 2 plus -1. 6 plus -3. 1 plus 6. -1 plus 2. -2 plus 3, and then 4 plus -1. Okay, and looking at actually reverse these, I actually did B plus C. In that case, we're okay because remember, with addition, it doesn't really matter which one you add together as long as you're adding. It's good there. Technically, we were doing B plus C here, and I should have reversed that one. But as long as it's addition, it's okay. Subtraction, that one you would have to specifically do it. If it was C minus B, you'd have to make sure you did all these numbers minus all these numbers. You'd have to kind of rearrange it there. But with addition, we're okay with doing that part of it. And then just, do what it says do. 1 plus 2 is 3. 6 plus 0 is 6. And then negative 1 plus 0 is negative 1. All right. 2 plus negative 1 is 1. 6 plus negative 3 is 3. 1 plus 6 is 7. Negative 1 plus 2 is 1. Negative 2 plus 3 is 1. And 4 plus negative 1 would be 3. Okay, so they ask you to find out what x is. Okay, x means we got to add the two things together, so then you go back and add them together, and then that's what you're going to have. Okay, and again, kind of got away with that one. I didn't catch it till we got started with it, but it was technically we did B plus C, but as long as it's addition, the order doesn't matter. If it was subtraction, you have to make sure you put the right thing first when you're subtracting on these. Okay, and then one other little side note they kind of put in here, and I don't know that it'll pop up a lot, but just in case they do. But a matrix with all zeros. Well, they call that a zero matrix just because that makes sense because everything is zeros. The other thing that they may do with that one, and this goes back to I think middle school, maybe like sixth grade or seventh grade, maybe even fifth grade, somewhere in there. We remember when y'all did all the properties, like you did associative and commutative property and all that. I didn't. They kind of say, all right, well, in this case, this is the. You also could call this the additive identity matrix. Because the additive identity property we had said you could add 0 to something and you get the same thing back. Well, if we're just adding a 0 matrix, it's basically the same thing now. Okay, so if you happen to run across those, just realize that the 0 matrix is what it sounds like. It's just a matrix with all zeros. And that may change. It may be a 2 by 3. It might be a 3 by 2. It could be a 4 by 1. But as long as you've got all zeros, then that's just called a 0 matrix. And again, the sizes of that one will change. All right, and then the last thing, addition, subtraction wise, that we'll kind of look at here before we get into some of the multiplication part of it, is they may also ask you to find some unknown values. And for that one, you should just have it already set up where you have one matrix equal to another matrix. All right, and all you have to do for this one is basically you just set each location on the left equal to the location on the right side, and then you just solve that equation. This would be one if you want to use your ditto marks, you can go back and do that. So basically just take the location on the left, set equal to the one on the right, and you solve whatever it says to do there. Okay, so for this one, we'll take the first row, first column number here, and set it equal to the first row, first column number there. It's the top left number over here, set it equal to the top left number that's over here. So we'll just do x plus 3 equal to 9. And you go, oh, well, that's easy. You just subtract 3 from both sides. We get x equals 6. There you go. There's one number. You don't have to do anything with this part because there's no variables. It's just -2s, so it's fine. The next one we would have would then be the y's. It's in the bottom left-hand corner here. So we've got y minus 1. We've got to set that equal to 2y plus 5. Okay, and then we'll just solve that equation, and once we figure out what y is, then we'll have that part of it. Remember, in that case, there technically is a 1 here, so if we're going to solve this one, we'll subtract 1y from both sides. So that's -1 equals y plus 5. Then just subtract 5 from both sides, so then y would equal -6. All right, and then we'll get to the last one here. Now, the good thing is on this one is, if it's the same variable here that we already had back up here, if we've already solved for x, you don't have to resolve this one, because sometimes they'll do that. They'll give you x's in 2 different locations. It should be the same variable either way, that if we did take this corner and set it equal, which you don't have to, you get x plus 1 equals 7, you get x equals 6. Sometimes they'll give that as a z, sometimes maybe not. So it just kind of depends on that one. So if you see more than one x, just realize that, it's once you got x in the matrix, you don't have to solve it again, because this will be the same answer that's here. So you don't have to solve that one for x because you already solved that one for x. All right, and then the last thing, and this is actually in the next section, but we're going to go ahead and talk about it a little bit today, and then we'll come back tomorrow and talk about it just a little bit more. Is I talk about scalar multiplication. And there's 2 multiplications that we have to do, and this is the easier one of the 2. And with scalar multiplication, it's basically this. You're going to multiply every element, which is basically when sometimes they talk about an element, that's basically every number. You could say location, all kinds of different ways you could talk about it there. It could be a location, it could be the number, it could be the element. They got all kinds of different names they can do it. Basically, you're just multiplying every single element of the matrix by a constant. In most cases, it's a whole number. They might occasionally sneak in a fraction on you, but even if with the fractions, it shouldn't be too bad. You may get some fraction answers, but that's fine, because you'll just leave the answer in fraction form, and it'll be okay. We'll look at whole numbers today. We might come back tomorrow and look at a couple of ones with some fractions on it. All right, so let's just show you the basics of it here. Let's say we've got this. Let's say A is 1, -3, 4, and then 5, 0, -10. And then they'll tell you to find, 3a or 2a or -6a. They tell you to find some number where you're just going to multiply everything out. And it sounds like what it sounds like. Just take every single number in here and multiply everything by 3. So this is going to become 3. 3 times -3 makes that -9. 3 times 4 is 12. 3 times 5 is 15. 3 times 0 is 0. 3 times -10 is -30. And most people go, hey, I like that, because it makes sense. You just take every single number and you multiply it by whatever number they give to you here. Now, again, sometimes they'll sneak in a fraction on you. That's fine, because if it was 3 over 7, then you would just take every number here and then go back and put it over 7. Not that they ask us to do that. If that had been over 7, that answer would have been 3 sevenths. That would have been 9 sevenths. That would have been 12 sevenths. So if they give you a fraction number, then you still just treat it the same way. It's just you're going to more than likely have some fractions in there. You may have some of these that would simplify, and you would get some whole numbers off of it. So whether it's a fraction, whether it's a whole number, just multiply it out. And if it comes out to be a fraction, just leave it as a fraction. Okay, now where they're going to kind of mix that in with what we were doing just a few minutes ago is they'll take a problem like that and they'll kind of make you do some work with it. May do something like this. Let's say that if A is, let's say it's 2, 8, negative 3, negative 1, 5, 2. And then for matrix B, let's go negative 1, 0, 5, and 2, 3, 2. Now here's where they could kind of go all over the place. They could do all kinds of different things on this one. May tell you to do something like this. Find 2A minus 3B. Okay, and for subtraction problems, this is one you actually kind of have two different options on this one. Because the 2A part is pretty straightforward. So we'll do 2A below this, just so we can kind of see what we're doing here. So take every single number here and double it, so that makes it 4, 16, negative 6, negative 2, 10, and 4. All right, now, and a lot of people don't do well with subtraction. Just, being honest with us here. So what you could also do in this one is if you have 2A minus 3B, just remember you could rewrite that as 2A plus negative 3B. So with subtraction problems, sometimes you can think about it that way, and it might make it easier because some people are like, well, am I doing 3 times B and then I'm subtracting it, or am I doing negative 3 times B? So you can look at it either way, that you can either do 2A minus 3B, but sometimes it's easier for us to do addition problems, so let's make that plus negative 3B. That we'll go ahead and do everything in here times negative 3, just so we can kind of have it so that at the end it'll be an addition problem and not a subtraction problem. So negative 3 times 1 is 3. Times 0, that one makes it 0. Negative 3 times 5 is negative 15. Negative 3 times 2 is negative 6. Negative 9 and negative 6. You could. Yeah, you could turn it, and that's what I was saying on this one, that if you don't like to do it that way, then we basically could. And if you just give me a second, we'll kind of show you here. We'll kind of do an if then. Yeah, you could do 2 times. You could go ahead and do 2A minus and then 3B. So you could have, again, it's your pick on what you want to do here. What was the numbers? 4, 16, negative 6. Negative 2, 10, 4. And if you just do 3 times all these numbers, and just remember subtraction, that's fine too. Yeah, so whether you do this or that, we'll kind of go ahead and do them both here because you should get the same answer either way. So now it's 4 plus 3, which would be 7. It's 16 plus 0, which is 16. It's negative 6 plus negative 15, which would be negative 21. All right, bottom row, negative 2 plus negative 6 is negative 8. 10 plus negative 9 is really 10 minus 9, so that's 1. And then 4 plus negative 6 would be a negative 2. All right, now again, if we were doing the 2A minus 3B, just to show you the same way here, we'll flip back here real quick. So that's 2A plus negative 3B. If we want to do 2A minus 3B, same type of thing. You just have to remember that it's 4 minus negative 3, so that's really 4 plus 3, so that would make that one have to be 7. It's 16 minus 0, which would still be 16. It's negative 6 minus 15, so that would be negative 21. It's negative 2 minus 6, that is negative 8. It's It's 10 minus 9, which is 1, and then it's 4 minus 6, which would be -2. So either way you go, it's still the same answer. It just, some people like it, and it doesn't really matter which one you do. Some people like thinking about it this way. Some people want to do it that way. Just remember that when you do this minus, you've got to do every single number. That it's this minus this, it's this minus this. So you got to be careful if you have the minus negative, just to make sure that doesn't throw you off a little bit there. But either way you go, either one of those two is fine, because you'll get the same answer either way. It just depends on which way you want to see it. Some people like doing it this way because they're like, okay, well, that makes sense because I'm doing 3 times B and I'm doing 2 times A. And then some people go, well, can we just go ahead and do distributive property with a -3? Yeah, if you do that, just remember then that makes that a plus sign in the middle. So it just, depends on which way you want to look at it, but either way is fine when it comes off.